Perfect. Okay. Good afternoon, everyone, and thank you for attending today's webinar on the IECC 2024 for residential buildings. This webinar is recorded, and the recording is posted to the Code Adoption Toolkit, usually within the next week or two. If there are any issues with audio, feel free to write me in the chat. And my name is Erica DeLello. I'm a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by Build Tank. So Robbie and I have been working with the Energy Office to provide trainings just like this one. This is part of a webinar series, so do make sure to attend the others as well. But we do offer role-based trainings as well that take a bit of a deeper dive on energy code compliance based on your background. So if you're an architect, engineer, inspector, plans examiner, contractor, rater, you name it, we've got training specific to your role and how to approach code compliance. I also want to note that we've got a couple of new webinars that were added to our schedule. There's one next week and then one in January as well. The one next week's on ComCheck. So definitely register for those as well. We do, let's see, we do offer those tailored group trainings if you are interested in a specific topic that isn't on our webinar schedule. But we also offer technical assistance for code adoption. So if you are a jurisdiction looking to adopt a new code, we have subject matter experts that support, say, speaking in front of city council or drafting your code amendments or navigating stakeholders. Whatever it is, we're here to support that transition. So feel free to reach out to me if you're interested in talking about it more. So most of you know about the Code Adoption Toolkit. It looks a little bit different than it did about a year ago. We put it into more of a PDF format and it's separated out by your background and what applicable resources are really applicable to your role. So definitely check that out. But the resource that I want to highlight is the Colorado Codes Helpline. This is a new platform that we're using as of, I think, September about. So if you have the old helpline bookmarked, make sure to change that out. And you can scan with the QR code right over here. Okay, so throughout the webinar, we want to encourage questions. So please use that Q&A function, and I'll let Robbie know at the end of the presentation. There's also the ability to raise your hand and ask a question at the end, and I can unmute you. And then lastly, there will be a survey window that pops up following the webinar. So if you could please take a minute to provide that feedback so we can continue to improve on these webinars, that would be wonderful. And I do have a poll that is launched right now. If you've attended this series before, or if it's your first webinar, we're trying to just track if we're getting any new traffic on these webinars. So it's helpful to have that. So I'll keep that open for a little bit longer, but now I will pass it over to Robbie to kick off today's session. And Robbie, go ahead and share your screen.
There we go. Thanks so much for joining us today. Today, we're going to be talking about the 2024 IECC and some of the significant changes. I'm actually going to take my video off until the end here, but if you have questions, don't hesitate to put them in the chat pane or question box, and we'll get to those at the end here. We have a lot to go through today. Okay, so we'll be talking about the ICC and kind of the trajectory of the ICC, the intent statement, which has changed pretty dramatically, and then we'll go through chapters 1 through 4 there. This slide is kind of getting us going here, kind of how the IECC has changed over time with reference to the 2006 IECC, which was one of the first times that the Department of Energy did a determination on what type of energy efficiency increases happened from one code cycle to another code cycle. So you can see that that's changed a bit over time. The big changes happened in the 2020 or the 2012 IECC, where we got about a 16 or a 19% increase in efficiency on the back of air leakage requirements. And then again, in the 2021, we got almost a 10% increase in efficiency when additional efficiency packages were added to the code. And then you can see, although the projection isn't completely out yet, it's projected to be between 6 and 8 points there. And largely that increase in efficiency, again, is gotten on the back of additional efficiency credits there. But also you'll see here that some changes have been made in the different compliance options in order to increase the efficiency of the homes that are being built to this code. So when we dive into chapter 1, we begin to talk about the scope of the code and the intent of the code. The scope documents changed a little bit. The code applies to the design and construction of detached and attached dwelling units. And then it talks about group 2, group 3, and group 4. And I just put a little refresher on the side there about what group 2, really 1 through 4 means. So if you don't know what that means, you can refresh yourself there. The bigger change happened in the intent. The intent used to be a small paragraph that combined 3 sentences, only 2 of which remain, but now it's a big paragraph, and it's really changed quite a bit here. So the first change is that the code is intended to provide market-driven enforceable requirements there. What that means, I think, is open to interpretation a little bit, but the idea is that, well, from my perspective anyway, the code, the energy code is unjustly being thought of as the code that is increasing the cost of construction, when in reality, all codes and code advancement increase the cost of construction. And we also need to remember that, especially coming out of the pandemic, material cost and labor costs and all other kinds of things are influencing the cost of construction there. So, but anyway, the code's also providing minimum efficiency requirements that result in maximum level of energy efficiency that is safe, technologically feasible, and life cycle cost effective, considering economic feasibility and so forth and so on. So you can see kind of this whole focus on cost, but also this new concept of life cycle cost effectiveness, which means that we need to begin to think about carbon potentially, or other things that are affecting the life cycle cost of our buildings and whatnot. Now, carbon isn't specifically referenced in the intent statement, so I don't want to misconstrue that there. But it does bring up the question of, what does minimum compliance mean, or what does the word minimum itself means? And I want to throw this out because we tend to have a negative connotation when we think about code specifically and the word minimum as referenced with code specifically. And I want to be sure that we all understand that the word minimum doesn't have a good or bad connotation. It basically means that through a national consensus body process, we have agreed that these minimum requirements ensure health, safety, and efficiency in our homes, and that you can go beyond that and get more health, safety, and efficiency, but the code is asking for a specific baseline of efficiency, which is deemed to be the minimum required. Again, that doesn't mean bad or good. It means basically that if you build to the minimum requirements of the code, you're going to have a well-performing house that meets those requirements, and people are going to, in general, be happy with that across the country. The majority of people will be happy with that. The intent statement does continue on and say that there are all these optional supplemental requirements that could be looked at from a code perspective to achieve zero energy buildings by 2030, and also that the Energy and Carbon Advisory Council, and approved by the Board of Directors, will look at those things from a policy perspective. But what this is ultimately doing is moving anything that has to do with additional efficiency beyond what the code is looking for, things like electrification or solar ready, or even carbon and carbon counting and carbon sequestration in buildings and whatnot will all be moved to the appendices and won't be housed inside the body of the code itself there in the future and now, I guess, as well. The code includes non-mandatory appendices, and that's where it ultimately is going. Requirements contained in the code will include, but are not limited to, prescriptive and performance-based pathways. So we need to remember that there are requirements in the code and their compliance pathways in the code. And the requirements are generally revolving around things that are required for how you install a specific provision that's in the code, and the pathways are demonstrating that you're meeting the energy budget requirements of the code there. So they're kind of two different things. The code will aim to simplify code requirements to facilitate the code's use and compliance rate. That's always something that the code is aiming to do, and that's what's happening right now as we begin the 2027 code development process, is that proposals are being made to help clarify requirements and make it more enforceable, and our ability to comply with those things will continue to happen there. And then the last part of the code includes, or this intent statement includes, statements that were already in the intent statement, these two last sentences, to provide flexibility, basically understanding the code and where flexibility is provided in the code really comes down to the compliance pathways in the code. And the code isn't intended to abridge safety, health, and environmental requirements. So we need to remember that we're talking about a suite of codes that work synergistically together to create safe, healthy, environmental requirements or efficiency requirements that take place in our buildings when we're building to the code requirements, not only from the energy perspective, but the IRC perspective and the IMC and whatnot. Again, these are a suite of codes that work together here. Here's an example of the appendices that are new to the 2024 IECC. And you can see that all those things that kind of go beyond the traditional building thermal envelope and mechanical efficiency requirements of the code have been moved to the appendices. So we see solar ready provisions, electric ready provisions, solar provisions, and so forth and so on. So if a jurisdiction chooses to adopt one of these appendices, they have the infrastructure already there to go in that direction there. So especially for things like the zero net energy residential building provisions and Appendix RC there. Okay, so above code programs can be used where such buildings also meet the requirements identified in table R405.2. So those are the requirements that are basically revolving around how you install specific things that are called out in the code. Generally, we're talking about insulation installation, air barrier and air sealing installation, installation that goes with regards to mechanical systems. So doing a proper manual J, S, and D, for example, those types of things are covered and put into the mandatory requirement table in the R405.2 section there. But there are some people or organizations that might come to you and say, can we build an Energy Star house instead of following the actual requirements of the code? And you can do that to some extent. Remember that you still have to abide by the mandatory requirements of the code that are listed in the R405.2 section. Also remember that the word mandatory has been taken out of the code, so requirements are required, which in essence means that they're mandatory there. Then we have the information on construction documents. This really hasn't changed much, but there is a section that's after that, after this, that is talking about solar ready systems there. And if you are going to adopt this section of the code, this solar ready provisions need to be put on the construction documents as indicated here. So even though it's not on that construction construction document section, the solar ready systems do need to be put on the construction documents. Then we get into the inspection section of the code. And I point this out because the inspection section of the code, this section right here has been added to it, air barrier inspections at framing and rough-in. But also you'll see that other sections of the code now call out specifically the inspection that's needed, but also kind of tailors it to the energy code so that we're looking at corresponding R values, correct location, and proper installation of the insulation that's been installed in our homes, for example. Now it talks about other components that need to be inspected, and again, it's kind of tailored it from an energy code perspective there, which means that we're really looking at our homes more from a performance perspective. We're looking at not only has the insulation been installed, but has it been installed so it works and performed, and does the R value that's been installed meet or exceed what the builder or architect proposed in their proposed compliance pathway to put into that building there. So we need to ask a question now, is it there, but does it actually work as it's been installed from the perspective of the code here? Which brings us to the last section in chapter 1 that I wanted to point out, which was approved third-party inspection agencies. This section has been revamped pretty substantially in order to help jurisdictions ensure that they're getting improved third-party inspection agencies that can help them enforce the code. So the third party needs to provide requested information to the authority having jurisdiction, but they need to demonstrate their independence and ability to actually do the inspections there. And the third party needs to ensure that they have the proper equipment, because the code doesn't prohibit a code jurisdiction from buying a blower door and doing those type of inspections. Most jurisdictions have not wanted to go that route, so we need to ensure that the approved third parties have the equipment to actually do those types of inspections that revolve testing mechanical equipment or whole house leakage in our houses there. This part makes it clear that generally speaking, it's not just an approved third-party individual that you're hiring, but it's a company, and we need to ensure that all the personnel within that company has the proper training to be able to inspect to the requirements of the code, and that the third party that you're hiring actually has the authority to perform the delegated inspections that determine compliance with the code, which means basically that if you are using an approved third party, that you're giving them the authority to approve an installation, but also say that it failed inspection and needs to be re-inspected to meet the requirements of the code. And then lastly, we have to keep records and submit reports and do all of those things that are required by this section of the code. So really what this section of the code is doing now is saying that approved third parties and authorities having jurisdiction need to have a conversation, create basically a scope of work so that everybody's on the same page about what you're giving them authority to inspect and what you're not giving them authority to inspect, and that you have the ability as a code official to approve a third party, but you also have the ability to disapprove that third party, which in essence takes out kind of this perceived or actual conflict of interest about who's actually paying for this third party to do their work there. So I urge you to take a look at this section and potentially utilize it so that we get better enforcement and compliance with the codes that are being adopted here. Now, the definition sections always change and morph. Some of the definitions get redefined and new definitions get added to the code, like knee wall or construction documents or ductwork. All these things get either redefined or added to the code. So you should always take a look at the definition sections to ensure that you're up to date there. This section didn't change dramatically, but I wanted to make sure that everybody was aware that these insulation certificates are required, especially for insulation that doesn't have an R value mark on it. We have no idea what the R value of these materials are. And these installation certificates are now required to be left immediately after the installation by the installer to certify the installed R value of the installed material, because nobody other than the installer actually knows what the R value is, because it's completely based on the density that they set their blowing machine to. So make sure that you're collecting those certificates after the installation and comparing it to what they've proposed to put in the house. Radiant barriers and all reflective insulations are now within the code in specific sections of the code in a much more robust way. So if you come across radiant barriers or reflective insulations, you now have places in the code to reference those things. Residential efficiency in chapter 4. Now moving to chapter 4, we're talking about requirements for air sealing and air barriers and insulation installation, as well as the compliance pathways that basically tell us to choose a compliance approach for permitting, comply with the provisions or requirements that are laid out in chapter 4, and then ultimately prove to the code official through testing or additional compliance documents that you've met the requirements of the code, and that what you proposed has actually been carried out to fruition to release the certificate of occupancy there. With regards to the compliance pathways, we still have the prescriptive compliance option, the simulated building performance compliance option, and the energy rating index compliance option, as well as the tropical climate zone that we won't really be talking about here. You still need to provide the certificate in order to get your certificate of occupancy. Some things have been added to this certificate, like the R408 additional efficiency measures and the location and dimension of the solar ready zone where one is provided there. These certificates are generally printed out of softwares when you're using a software-based compliance pathway. When you're not using a software compliance pathway, you might see a certificate that's hand generated, like the one on the right here, for the R value compliance approach, for example, that doesn't have a software accompanying it. The building thermal envelope is basically prescriptive pathways, basically brought down into two pathways. You can either use the prescriptive R value, U value table, or you can use what's now called the total component performance alternative. It used to be called the area weighted U value or UA performance alternative, but you'll see here quickly why that name has been changed. Remember that if you choose to use the prescriptive R value, U value table, that it is the least flexible compliance option there. There's really no compliance tool other than declaring to the code official that you're going to use the thou shalt do prescriptive compliance R value table there. You need to add those R values to your permit set, and then through inspection and in documentation, you'll have there. There's no longer a mention of the additional efficiency packages in this specific section, as was done in the 2021 IECC. You need to go to section R408 to see anything that has to do with additional efficiency packages. But we do need to note that the additional efficiency packages are only in relationship to the prescriptive compliance options here. The performance compliance options have a different way of getting that additional efficiency that we'll see here in a minute. Now, the R value and U value tables have been reoriented. Their XY axis has changed so that all the requirements are down the left-hand side and the climate zones are down or across the top here. But the actual U values haven't changed that significantly here. Same with the R value table here. You can see in climate zone 5, these are the changes that happened in climate zone 5. So there are changes that happened in both these tables, but the most significant change is the reorientation of the table, which the code development body felt made this table more easy to read and understand there. You also want to always look at the footnotes of these tables. The footnotes talk about how R values When insulation is compressed in a cavity, it changes its R value. It tells you what continuous and cavity insulation means. It gives you some variance or ability to change the U factor of windows in certain climate zones. So you definitely want to review the footnotes that are associated with these tables. And just as a reminder, the U factor table is talking about the assembly of things there. So the U factor of a window, for example, is talking about the window in its entirety, its assembly, the wood frame, the edge spacer, the 2 layers of glass, the gas that might be in there, the hardware that's used to open and close the window. All of those things come together to create the U value. Each of those things have a component R value, and R value is the reciprocal of the U value, or the U value is the reciprocal of R value. So basically, the R values table and the U value table are expressing the same thing in different ways there. One is an assembly and one is a component that you put into the assembly there. Okay, the other modeling approaches for compliance here are either the prescriptive component performance alternative, the simulated building performance, or the energy rating components. This gives you more flexibility. It helps you understand the cost effectiveness of the components that you're putting together, the assemblies you're putting together to demonstrate compliance. And it improves the professionalism of our contractors in industry, because we need to really think about what we're installing in our homes rather than being told what to install in our homes. The best thing about these different compliance approaches that use an energy modeling software is that you can try and fail 10,000 times before you buy a nail to build that house, and ultimately succeed in meeting the requirements of the code there, because they allow you to do what we call a trade-off. The trade-off allows you to put something more in one location so you can put something less in another location. So in this example, if I decide to put R38 attic insulation in the attic, that would be represented by the blue ball here. I might need to choose 3 other things to do something slightly more on in order to keep the balanced energy budget that the code is requiring us to achieve here in order to demonstrate compliance with the code here. There are 3 softwares that allow you to do these types of energy trade-offs or energy compliance pathways. Reminder that the ResCheck software only allows you to do the total UA alternative, or what is now called the total component alternative approach there, whereas REMRate and Ecotrope softwares allow you to comply or do energy modeling for all of the compliance approaches there. So the next compliance approachway is the simulated building performance approach. The key changes here is that we're now talking about dwellings rather than homes or buildings here, making sure that we understand that these performance approaches can be used on attached dwelling units or multifamily 3 stories or less dwelling units as well. The requirements table has been modified a little bit, so making sure that we understand that all of the requirements that are detailed out in section R402 through R404, how you install these things, are required by this pathway as well. The envelope backstop changed, equipment in the reference home changed, ductwork in the reference home changed, and so forth and so on here. So going to the backstops, you see that the backstop has been changed to be focused on the total conductance through the building thermal envelope here. And this is why the additional efficiency packages aren't required for this compliance pathway, because if you're in climate zone 3 through 8, now your total building thermal conductance has to be 15% better than what would normally be required by the 2024 IECC here. So in essence, the additional efficiency packages are getting that 15% increase in efficiency there. And and so to give you that same type of flexibility, you just have to now get 15% efficiency in your total thermal conductance for while you're doing the energy modeling. So you're able to choose a variety of different ways of doing that with your building thermal envelope in this pathway. So it gives you still a lot of flexibility, but the new requirement is that you have to be 15% better if you're in climate zones 3 through 8. This part of the simulated building performance compliance approach is talking about ensuring that if you have a large home, that you are also reducing the energy efficiency of the house through the building thermal envelope by an additional 5%. So that's kind of a new thing, that house size is a thing that's being taken into the equation here as well. Here. Basically, what they're saying is that the simulated building performance approach is a more holistic energy model, and therefore you need to look at it in a more holistic way, and that can affect compliance when you have bigger buildings there. So you want to take that into account here. In the reference home, now you are looking at heat pumps, furnaces, air conditioners, and water heaters. And the 2024 IECC ties the reference homes to these equipment efficiencies to the federal minimum efficiencies. So now if you're installing a heat pump that has an efficiency that is significantly better or more efficient than the federal minimum efficiencies, you're going to get credit in your trade-off budget for this. So again, you have more and more flexibility here. And you can see that if you go into the reference home itself here, that's published in section R405.4.2. You can see how it's talked about in the reference home versus what you're proposing to put in that house. So again, if you propose a heat pump that has a COP of 3, you're going to now get credit for that in your trade-off budget there. Ductwork is in the same way, where the ductwork is located now is something that can give you additional trade-offs there that weren't available in the 2021 and earlier code editions there. So if you have ducts all located in conditioned space, you're going to get some trade-off credits for that. Remember that the softwares that can do this type of energy modeling does not include the ResCheck software. You're only looking at REM rate, Ecotrope, or potentially Energy Gauge. You're unlikely to see the Energy Gauge software in our climate zone here because it's primarily used in Florida. Also, we need to understand that as a byproduct of the simulated building performance approach, you might see a HERS energy rating index generated, but the HERS energy rating index score is not an index score that can be used for compliance with the IECC here. The energy rating index alternative that's used in the IECC has changed a little bit. Again, references to dwelling units, the requirements that are in, it should be table R406.2, not 5. There are ensuring that the requirements that are in the R402 through R404 sections are implemented, as well as the envelope backstops and other requirements here. So let's go in and make it clear that the envelope backstop is the same backstop that was required in the R405 section, basically ensuring that the thermal conductance of the building thermal envelope in climate zones 3 through 8 is 15% better than. Again, you don't have to deal with additional efficiency packages in this pathway because this is how you're getting that additional efficiency through this backstop here. When you're calculating the energy rating index score up until this code, the 2024 IECC, there was an amendment to the ANSI standard 301 for how you calculate the energy rating index score that removed that changed the ventilation, how ventilation was calculated in the software here. That portion of the code was removed in the 2024 IECC, and now the ANSI standard 301 is being used as intended there. The ANSI standard is also what's used to calculate the ERI for the HERS Energy Rating Index, but those scores now are closer together, but they won't be exactly the same for a variety of other reasons that we don't have time to go into, but you should know that they are closer to each other than they ever have been. Now, the ERI compliance approach here is asking you to do an energy model to benchmark the house on an energy rating scale and then determine if the energy rating that that house gets is equal to or less than the energy rating requirement that is detailed out in this table here. You can see in climate zone 5, you now have to achieve an energy rating index of 54 or less. And if you also install on-site power production for that house, you now have to be at least below a 43 on this table here. So you want to make sure that you're looking at the on-site renewables that you're installing here that are called out specifically in the R406.5 section here. And it says that the energy rating index shall be permitted using the average dwelling unit energy rating index. Here, that's number 2 in the exceptions, which is basically meaning that if you have a stacked multifamily building that's 3 stories or less, that's governed by the residential energy code, that you don't have that you can use an average of all of those scores to comply with the score here. Although you will see here in a second that sampling is allowed too, specifically for energy rating index scores and performance testing requirements here. Verification of the approved third agency specifically for this path has changed a little bit here. You can use the third party to develop the ERI score, but you still need to make a choice about all those requirements, the R402 through R404 sections. Are they going to be completed and inspected by the authority having jurisdictions or by the approved third party? And therefore, you need to go back into Chapter 1 in order to understand what's who's required and that the third party has the same skill levels as your jurisdiction inspectors do. The compliance softwares that have been available to do compliance for the software compliance approaches now are being looked at a little bit more closely by the IECC. There's this section that says that the ERI software shall be using approved software tools that are defined by the ANSI 301 standard there. You'll see also in the R405 section that there's a reference to approved softwares and that basically my belief is that sometime in the future, ICC is going to ask ResNet to have better oversight over the softwares and how softwares are interpreting the code within the body of their software there, which really isn't happening at this part, although this is a step forward in the right direction there. Okay, so now we're moving away from the different compliance pathways to the actual requirements in the code. The requirements of the code, the requirements of the code are listed in R402 through R404 section of the code. And starting with ceilings without attics, you'll see that the R value reduction in the prescriptive compliance pathway in the prescriptive R value table needs to be reflected in this ceilings with attic spaces. In essence, this section gives you the ability to do a trade-off when you're using the R value prescriptive compliance approach here, but it's also not only allowing you to reduce the R value, but it's also saying that that R value needs to be installed completely over the top plate. Therefore, you're probably going to have to install a raised hill truss in order to get that full depth of insulation, uncompressed insulation over the top plate there. And that's why the requirements that are listed within this section for how you install something are required regardless of the compliance approach that you actually use. Knee walls are new to the code in the 2024 cycle there. So knee walls are defined also in the 2024 as a wall that separates conditioned space from attic space or unconditioned attic spaces there. So you want to look at the knee wall section to make sure that you understand all the requirements that are associated with knee walls, not only there, but also in the air barrier, air sealing, and insulation installation table. Steel framing has been modified slightly. Steel framing and ceilings, walls, and floors shall comply with the insulation requirements in table R402. That's the R value table, and the U factor requirements in table R401.2 here. And then also within the table that is specific to steel framing, that's in the code as well here. Floors this section has been modified a little bit, again, because you're now allowed 3 different ways of how you install the insulation in the floor section here. They have broken it out even more in order to try to make it more clear about the different ways that the installation of floor insulation is allowed now. In the same way, the slab insulation installation section that is specific to alternative slabs. Basically, when you're installing slab insulation for the R405 or R406 pathways, you have the ability to trade it off or install less insulation, or potentially install the insulation itself in different ways than might be allowed in the other compliance approaches there. And so that's called out specifically now in this alternative slab on grade insulation configuration here. Crawl space wall insulation now references the table floor insulation installation section R402.2.8, which means that if you have a vented crawl space and you're insulating that floor system like this gentleman is doing, you now need to sheathe the bottom of that floor assembly in order to make it work and to be in compliance with the R402.2.A floor section that we briefly went over earlier here. There is this alternative crawl space wall insulation configuration, which again is in reference to sections R405 and R406, those performance energy modeling compliance approaches where you might install either less insulation or install the insulation in a different configuration there. Radiant barriers, as I said earlier, are called out specifically in this section as well now, so you need to look at those. And those are the biggest changes in the R402 section there with regards to insulation, air barriers, and air sealing. The air leakage testing section now gets us into the air sealing, air barrier, and insulation installation table. There have been a couple key changes here. The addition of knee walls to this table, addition to fireplaces and common walls or double walls like shaft liner area separation walls. The details that are required on your construction documents largely come from this section of the code. These requirements are again, requirements, basically mandatory in the code. Therefore, we need to be able to install them properly and ensure that the information from that table gets out to the field so that they get installed properly. So these are details, for example, for how you install the air barriers properly in a drop ceiling here, or in a knee wall, for example. This is the new knee wall section. The knee wall shall have an air barrier between conditioned and unconditioned space. and that the insulation in that knee wall shall be installed in accordance with section R402.2.3, which basically means that the knee wall insulation needs to be the same as that of any other exterior wall insulation. And if it's not, then you need to move to a software energy modeling compliance approach rather than the R value table compliance approach there. Testing requirements, again, have been clarified to ensure that we know that that every sleeping unit in a building, in essence, every dwelling unit in a multifamily building needs to be tested there. There are some exceptions for attached garages, which is basically saying that an attached garage, whether it's insulated and heated or not, is always outside the building thermal envelope, and therefore it does not need to be tested by itself or in conjunction with the rest of the building there. Dwelling units now can be sampled. So if you have a dwelling unit that is greater than 7, then 7 of those units, 20% of those units actually need to be tested. Or you can test 100% of them as you normally would. The maximum air leakage rates have changed as well. Now it's based on climate zone. So in our climate zone 3 through 5, it hasn't changed. You still have to reach 3 air changes per hour there. And now it's more clear that clearly speaking to compliance pathways R405 and R406 that you do have the ability to trade upward. In essence, your air leakage can be worse if your R values in your building thermal envelope are better. It's not normally how we do a trade-off, but that type of trade-off can happen that way there. So you want to take a look at that section to make sure that you're understanding what the maximum air leakage rates are per your climate zone. Again, in climate zone 3 through 5, it really hasn't changed. We're still at 3 air changes per hour here. You are allowed some exceptions to use a different metric for air leakage quantification, basically a CFM per square foot of enclosure area metric if you have attached housing, or if your building dwelling is less than 500 or 1,500 square feet of area as well. So that's floor area we're talking about here. Okay, section R403 deals with systems, and these systems have had some changes. There's some understanding that we're installing more and more heat pumps, and therefore we need to think about the supplemental heat there. That section is new to the system section in the code here. Duct systems, we've always had to design our duct systems in accordance with Manual J, which gives us the heat load calculation, and Manual S that ensures that we have the equipment that has the capacity to meet the load that we calculated in Manual J. But we never really talked about Manual D or designing a duct system to install in the house. So duct systems now need to be designed in accordance with Manual D, which is an ACA manual that talks about clearly designing a duct system and understanding the friction rate and the losses that happen through duct systems there. So this is the section that hasn't changed, that ensures that we're using Manual S and Manual A there. But in essence, those things are things that need to be enforced in the code, and Manual D has been added to it.
Hey,
Now,
Robbie,
yes.
I just want to interject. I know we only have 10 minutes or so left, and you still got some content to go through. So if we need to, we can always add another session so that we don't have to rush through some of the content, if that's better for you. Because I know people want to hear about the significant changes and understand them. So just an
Yeah.
idea, take your time, and then if needed, we can always add another one, another session or something.
Okay. What I wanted to point out in this section is that these pieces of the R403 section of the code really only impact the R405 and R406 energy performance compliance pathways because they address things that you could take advantage of in your trade-offs. So for example, if your duct's located inside conditioned space or it's insulated better, you could take advantage of that in your energy trade-offs for your compliance approaches. With regards to duct leakage, the duct leakage system has been defined more holistically in order to ensure that the duct systems in their entirety are tested. The buildings complying with sections R405 and R406 need to be tested in accordance with a new standard that has been added to the code there. And the compliance metric that you're using to demonstrate compliance with the duct leakage requirements has changed and it's been put into a table. So now if you have a certain number of returns in your house, you might be allowed to have slightly more leaky systems than otherwise here. And if your houses are smaller than 1,000 square feet, you're at a fixed level of required duct leakage that you have to achieve here. So you want to look at the duct leakage metrics that is put into this table now here. Dwelling units can be sampled for duct leakage as well, so you want to look at that as well. With regards to hot water pipe insulation and other hot water systems, these sections of the code are new and or have been revised slightly as well. Mechanical ventilation systems are governed by the code here, and mechanical ventilation requirement that you put in a balanced ventilation system or a energy or heat recovery ventilation systems has dropped down to climate zone 6. So now climate zone 6, 7, and 8, you have that requirement to put in a heat recovery ventilation system. As always, since the 2021, you're required to test all ventilation systems. So that's bath fans, kitchen hoods, whole house mechanical ventilation. And that testing demonstrates that they're compliant with the IRC requirements for how much air these systems are required to push. And you are allowed to sample that rather than test every single system in a home. Intermittent exhaust controls for bathrooms and toilet rooms is new to the code. So you're going to see that there's a whole section here that's dealing with controls and electric systems here that is new to the code. And you'll want to make sure that you're aware of those systems that, requirements and that you're looking for them there. Section R404 deals with electric power lining and renewable energy systems. Now, instead of a percentage of all luminaires being required to be energy efficient, all systems are required to be efficient. Basically, we're looking for LED lamps in all fixtures is really what this section is getting at there. Lighting changes have dealt with exterior lighting, interior lighting controls, exterior lighting controls, and renewable energy certificates that are governed by this section of the code here. So you want to make sure that you look at those sections there. You can see that the lighting section is starting to mirror what we see in the commercial section of the code as well. And then lastly, we have the R408 additional efficiency requirements. Remember that the R408 additional efficiency requirements are specific to the prescriptive compliance alternative only there, that the additional efficiency has been gotten through the backstop in the R405 and R406 sections. So what you want to know is that you have to get at least 10 credits from the section if you're using the prescriptive compliance alternative here, and that those 10 credits are roughly increasing the efficiency of that pathway's compliance by about 15% in climate zones 3 through 8, in the same way that the 15% thermal conductance backstop is increasing the efficiency in sections R405 and R406 there. So you're now given these credit choices in all of these different categories here. So you'll see that there's a table within the R408 section, and you need to choose in your climate zone what you like to do, and it gives you a point per climate zone what you can do. So if you choose, let's say you choose ground source heat pumps, you'll see that ground source heat pumps in every climate zone is more than 10 credits. You will have to choose at least one more credit from that zone there. So that goes back to these requirements. A minimum 2 measures must be implemented there. So even though you have to get a total of 10 credits, if you choose a credit that's already given 10 or more points there, you'll have to choose a second credit there. Okay, so yes, I do believe that we need to break out these sessions into longer sessions to really get into the significant changes. You can take advantage of my session at the Colorado Institute's Code Education happening in March there, that conference in March. We'll be going through these in much more depth, or other Colorado Energy Office trainings that are coming up that will look at sessions broken out, sections of the code broken out in more depth so that we can get into more detail about specific changes there. But basically, I want you to be aware that there's a lot of flexibility that's based in the code, or that's allowed in the code. But as the Dalai Lama says here, we need to learn the rules so that we know how to break them properly. So you need to go into those compliance options and learn about the trade-offs that are allowed there so that you don't have to be just told what to put into the assemblies. You can figure out the most cost-effective ways to build the assemblies that meet the intent of the code. You can see that a lot of the details that have been added are starting to mirror the commercial section of the code, that there's some electric infrastructure that's been added to the code, and that the R408 additional efficiency options now only reflect requirements for the prescriptive compliance pathways, because the other compliance pathways are increasing their efficiency through their backstops, and that anything that's innovative in the code with regards to going to zero or solar or electric ready has been allocated to the appendices and is now optional for people to potentially adopt there. So happy to stick around and discuss or answer questions. Here's my contact information if you have anything that you'd like to ask me specifically. You're more than welcome to reach out to me as well as using the code hotline.